every last Friday of the month, we reserve this half hour to the kids, and we usually focus on school going kids, to ask their questions to Dr. Chris Smith. And today we're speaking to the kids from the AKA Snapshot Study Group, a community based tutoring program driven by Andrew Koopman, who's opened up his space to say, kids, after school, you need extra help with particularly your STEM subjects? Do you need just a place to do homework quietly and in a safe space? So I want to welcome to the show today Andrew Koopman from the AKA Snapshot Study Group. Andrew, are you there this morning? How are you?
Good morning, Lester.
First, Andrew, I need to play something for you. Of course, you know Professor Brian Cox. He tries to tell the world through his interesting documentaries about the world and the universe. I found a video and I saved it specifically for you. It's a young man in the UK who sings songs in the style of Brian Cox. I just want to play a little bit for you, and I want to get your critique. Just have a listen.
Look at the stars, look how they shine for you. Well, in fact, they don't just shine for you, they shine for billions and billions of life forms here on Earth. And in fact, not all of them do shine for you. Even the most luminous of stars can only be seen up to thousands of light years away, which is not that far in terms relative to our observable universe. And not even all of them are yellow. They can vary depending on temperature and age, from red.
Chris, the kids are absolutely brilliant. Your knowledgeable critique on a kid called Hard Shakes online doing Coldplay's Yellow in the style of Brian Cox.
I thought it was brilliant. I'd quite like to hear a bit more of that, actually. Can you tweet the reference so we can play the whole thing later in our own time, of course? It was brilliant.
I will send it to you. But let's get to the business of getting the kids to ask the tough questions. Andrew Koopman, are you there with us?
Yes, I'm here, Lester. Good morning.
Excellent.
Good morning.
Let's just
Dr.
jump.
Smith.
Dr. Smith is excited. Let's jump straight into it. First, we have Tiana Erasmus, who is a grade 5 learner. Tiana, good morning.
Good morning.
Morning.
Tiana, we are listening. What is your question to Dr. Chris Smith?
My question is, what is stars made of?
Hi, Tiana. Well, I suppose you could begin by saying, well, how would we know? Because the nearest star is our sun, and that's millions and millions of kilometres away. So no one's ever been there, and it's far too hot. If you go to just above the surface of the sun, it's millions of degrees and you would melt. So how do we know what stars are made of before we even can tell you the answer? Because it's always important to know how reliable an answer is when you do anything in science. And the answer is that we can thank the chemist Robert Bunsen, who invented the Bunsen burner that you see in use in laboratories and chemistry classrooms. Because as well as inventing the Bunsen burner, he invented the science of what we call spectroscopy. He realised that every chemical element, and there are more than 100 of those, that everything is made up of in the universe, those elements, each of them absorbs light and emits light at a certain colour. And so if you look at the colour of light that comes to us from an object, it tells you something about what's in that object. And we can use that to work out what's in a star like the sun. And when we point our telescopes and look at the colours coming from stars like the sun, you can see a massive signature of hydrogen, you can see a bit of helium, and you can see some other simpler elements. But as they get bigger, there are fewer of them. So most stars start out mostly made of hydrogen. And they use the process of nuclear fusion to squeeze together these very small hydrogen atoms to make bigger and bigger elements. And as the star gets bigger and it gets older, it squeezes together bigger and bigger elements to make even bigger elements, up to a certain point. And then when the star blasts itself to pieces, if it's big enough at the end of its life, it produces a whole raft of other, even more exotic elements, including gold and some of the things that we value very highly here on Earth. And so we've got science from the 1800s to thank for knowing what stars are made of in the 21st century.
Nehemia Simons. Good morning, Nehemia. Are you there with us? What's your question?
Morning. How do ants breathe?
Breed or breathe?
Breathe.
Okay,
Breathe.
ants are insects, and insects don't have lungs like we do, but they do have air passages called spiracles. And if you look down a microscope at an ant, you would see down the side of its body on each side are these air passages. And you've probably noticed that insects have a bigger abdomen, and they often move their abdomen backwards and forwards. They sort of squeeze it in and out like a squeeze box in a concertina way. And what they're doing is pushing air up and down through those airways or spiracles. And that brings the air into close contact with a big bag of juices inside the ant called a hemocoel, which is ant blood effectively. And the oxygen moves out of the air in the airways into that bag of fluid, and the waste products, the carbon dioxide the ant is effectively breathing out, moves out of the bag of fluid and into those airways. So although they don't have airways in the same way humans do, like lungs, they do have airways that help to move gases in and out of the ant.
Andrew, before we get Carmen up and ready, tell us a little bit about the AKA, the Snapshot Study Group. What is its purpose? What role do you play in the community of Mitchells Plain?
Thank you, Lester, and thank you, Dr. Smith. What we do is for the disadvantaged learners, we are assisting learners in an after-school program is now 6 days a week. Those that don't have resources, we have tried now to give those resources like data for online tutoring, data for research work. When they have homework, they come and do it here and they ask their peers. We have in the past and are still producing top students, changing their lives and getting them to be the best that they can be with our assistance. We take them on excursions, we take them to career days so that the children are exposed to different career paths, so they have a reason to study. They know they're going to use them.
And I'm sure there's going to be lots of inspiration by the next 20 minutes with Dr. Chris Smith. We have Carmen Williams, who's in grade 6. Good morning, Carmen.
Morning. My question is, how does a person get chickenpox?
Oh, hi, Carmen. Well, believe it or not,
Hi.
it's got nothing to do with chickens. And we think that it gets the name chickenpox because of smallpox, which was another virus of a totally different type hundreds of years ago. But smallpox was really nasty and chickenpox was really very mild. So people called it chickenpox to show that it was just a chicken of a virus. It wasn't going to do much harm. It's a kind of virus and it spreads via the air. So when a person has chickenpox, they breathe out the virus, and also the rash, the spots they get on their skin are full of virus, and when they pop, they release into the air a cloud of virus, and anybody who's nearby who hasn't had the infection breathes in those particles. You don't need very many of them, and they settle in your airways, and they infect the cells in your airways, and they grow lots more virus there, which then spreads all over your body through your blood and gets into all of your tissues, and it grows even more virus. And because the virus starts to grow in your lungs, that's why you can breathe it out. But because it's going all over your body and you get the infection of the skin, you get those blisters. And once it's done that, it then goes into your nervous system and hides in your nervous system for the rest of your life. So about 90% of the population in South Africa have had chickenpox. Same in the UK. And that means that if you go to 9 people out of every 10 in the country and just pick them at random and you look in their nervous system, you will find the virus hiding in there. And periodically throughout your life, it can come back. But it doesn't come back all over your body like chickenpox. It comes back in just one patch of skin, and it's called shingles, and it's very painful, but it produces the same blistering rash, and it's fully infectious, and that's how the virus can then come out of there and infect another person again. So it's a clever virus. It either causes you to be infectious with chickenpox or later in life infectious with shingles. But a very clever group of viruses called the herpes viruses, and that's how they spread.
Abigail Simons.
Morning. My question is, why are sunsets red?
Abigail, good morning. The answer to this is when we look up in
Morning.
the sky and we see the sunshine, it looks like a white colour. But if you were to analyse the light that's in sunshine, you'd see it's a mixture of colours. In fact, it's all the colours in the rainbow. And it's just when all those colours hit our eye together, it makes the light look white. Now, when the light from the sun comes through the Earth's atmosphere, which is full of oxygen and nitrogen, it gets scattered a bit, but not all the colours, just the blue colours. And that's why the sky looks blue, because the blue light that's in there has been bounced about all over the sky by the atmosphere. And that makes the light look a bit more red. So the more atmosphere that the light has come through to get to your eye, the more red it looks. And as the sun sinks down towards the horizon, it's coming over and through the greatest distance of atmosphere between it and you, and so therefore the greatest amount of blue light is scattered out. And if you remove blue from white light, it makes it look much redder. And so you see light that looks more and more red when the sun's on the horizon. So at sunrise and sunset, the sun looks much redder than it does when it's directly overhead at noon, when it looks much whiter.
Chris, before we get Peyton next on the line, is it true that a sun that is dancing on the rim of a hill or just on the horizon is actually what we see? Of course, you don't look directly at the sun, but usually if it's on the horizon looking over the water, the sun that we see is actually not the sun and actually just an optical illusion.
Well, the light will be warped a bit as it comes through the atmosphere, because when light goes from one medium into another, then it does change its speed, and if it changes its speed, it bends a bit. So the light won't follow a completely straight path to reach your eye. So it is true that it will be slightly kinked, but what you're seeing is effectively the sun, but the sun as it was 7 or 8 minutes ago, because that's the other thing to consider. The light has a finite speed. It's travelling at 300,000 kilometres a second, and that means it takes about 7 or 8 minutes for the sunlight to get from the sun out to us here on Earth. So there are two aspects to that question which are interesting.
It is the Naked Scientist. Unfortunately, not taking your listener questions today because we have the kids from the AKA Snapshot study group out in Tafelsig in Mitchells Plain. Every last Friday of the month, we let it loose with the kids. We focus on a school in and around Cape Town. So if you'd like to nominate a school of who should be next in our Naked Scientist Kids edition, let us know. Drop us a WhatsApp, 072-567-1567. And Andrew, there are already a couple of messages here with people really excited about what you guys do. They want to donate some books, some fiction and some non-fiction books to your study group. So really, really good news. And thanks for the great work that you guys do there. Peyton, what's your question to Dr. Chris?
What is the other planet made of?
What are the other planets made of, Chris?
Hello, Peyton. Well, planets are of two types, at least around our sun. We've got rocky planets, like the Earth, and there are 4 of those. There's Mercury, which is closest to the sun, Venus, which is next, the Earth, and Mars. And then there are, beyond them, what we call the gas giants. So there are gassy planets, and we've got Jupiter and Saturn and Uranus and Neptune. And then we've got further out dwarf planets, which are things like Pluto. So the gassy ones are big balls of hydrogen largely, and a few other things mixed in. So those are the 2 real main types. Rocky ones, which have got a lot of iron in them, and aluminium and silica and things like that, which are close to the sun, and gas giants, which are made of hydrogen, which are much farther away from the sun. And then there's icy balls and comets and things, which are much further out beyond those.
Up next, Seneca, was it Seneca Hendricks, you're in grade 4. Good morning, Seneca.
How many bones is in a human being?
How many bones in the human body, Chris?
Hello, Sanika. If we're talking about an adult like me and Lester and Andrew, then the answer is 206. There are 206 bones in an adult human. If we're talking about a younger person, like a newborn baby and someone who is getting up to your age, then it's more than 330 odd. And the reason for the difference is that young babies have more bones than grown-ups because as they grow up, babies' bones join together. So two can become one. And so you start with more bones and join them together to make fewer bones, and ultimately about 206 in the average human adult.
Who's
Okay.
next? Daniel, Simon, in grade 5. How old are you, Daniel?
11.
11 years old. Very curious,
Yeah.
11-year-olds. What's your question to Chris?
My question is, how does earthquake happen?
How do earthquakes happen?
Hi, Daniel.
We
It's interesting,
recently-
that question, because we were talking, me and my colleagues earlier this week, about earthquakes not on Earth. There's a probe which is called InSight, which is on Mars. And actually NASA, who put it there, are going to have to turn it off because its solar panels have got covered in dust. So it's not working very well anymore. But it was put there to measure the equivalent of earthquakes on Mars. So these were called Mars quakes because we want to understand the process by which they happen. And we know that it's not just Earth that has earthquakes. But the reason they occur is that the surface of the Earth is broken up into what we call tectonic plates. So there are big chunks of material that float around across the Earth's surface, and they are jostling against each other. They're all moving around, and they're moving at most of them roughly the same rate that your fingernails and toenails grow. And when they rub up against each other, one goes one way and one's trying to go the other way, and they can squeeze together. And as they do that, they're obviously storing energy. It's like you winding up an elastic band. And the energy gets stored and stored and stored, and the tension goes up and up and up between these two plates where one wants to go one way and one wants to go the other, and neither will give way. And then at some point, one will go and they'll slip past each other, and all that energy, like the elastic band that's been coiled up very tightly, will suddenly be released all at once. And this will cause a big change in movement or direction. And as a result of that, you get a vibration, and these shock waves will spread through the area from where the plates have slipped past each other, and they cause the shaking. And in some cases, it's going to be sufficient to bring down buildings or cause damage. In other cases, it's just very minor. There's one other form of earthquake that can occur, which is in countries like mine, in the UK. About 10,000 years ago, there was an ice age, and the whole of the UK was under kilometres of ice. And that pressed the land down into the earth. But as the ice melted when the ice age finished, the weight was removed, and so the land started to come back up again. And as it comes back up again, it can sometimes do it in fits and starts, slipping and stopping, and that's called post-glacial rebound. And you do occasionally get very small minor earthquakes from that too.
Thanks so much for that. Who's up next? Is it Michael? Michael Schroeder?
Yes,
Schroeder?
Mr. Schroeder.
Michael Schroeder. Hi there, Michael.
Hello. My question is, if Earth is round, how do we never fall off?
I could never understand that when I was first trying to become a scientist. I couldn't understand how people in the southern hemisphere, like you guys, were not upside down, or looking at it the other way, why I wasn't upside down when you're the right way up. But the reason for this is the Earth is huge. The distance between where you are on the Earth's surface and the centre of the Earth is 6,000 kilometres, give or take. A really long way. And that means that the curvature of the Earth, the amount it's sloping away, is very, very tiny relative to you. And so it doesn't look like anything other than a flat surface when you're as big as a human is. And it's only when you look over very big distances that you realise the Earth is curved. And what's holding you down onto the Earth is gravity, which is pulling you towards the centre of the Earth. So all the time we're being pulled down onto the Earth's surface by gravity, and because we're small, the Earth looks flat to us, but is in fact very gently curving. And so if you kept on walking all the way around the Earth, you would go around in a big ball, but over the short distances that we tend to be familiar with, because we're small, it looks flat.
I think we have time for maybe 2 more questions. Is it Diego? Diageo?
Morning.
Morning, Diego. How are you?
Fine, thank you. My question is why doesn't sand dissolve?
Why doesn't sand dissolve?
Hello, mate. Well, the answer to this one is that sand is tiny particles of rock. So if you start with a big rock and you smash it up and smash it up and smash it up, it breaks up into smaller and smaller bits and you eventually get sand. And that's how sand forms at the beach or in a desert. It's rocks rubbing against each other because water moves them about and bashes into them and not rubs one against the other, and then small particles in the water also rub against them, and it basically knocks small bits off until you get down to this lovely sand. And because rock doesn't dissolve, because it is a mineral that has a particular chemical formula that means it won't dissolve in water, it's a solid, sand doesn't dissolve because it's basically small bits of rock.
And we
Thank
have
you,
time
Chris.
for one more squeezing in perfectly. It's Diego's brother, Jonathan. Good morning, Jonathan. You have the honor of asking the final question.
How does a bird fly?
How does a bird fly, Chris?
Good morning, Jonathan. The answer is birds have wings, of course. We can all see that. And when a bird flies, it's very, very light. Birds are mainly all feathers and empty space, air. So their skeletons are very light, their bodies are full of air, and that means that there's very little weight to move around. So that helps them. And what they're doing is flapping their wings. And when you flap your wings, you push air down. And because of a very clever scientist from about 300 years ago who realized that when you push on something, it pushes you back as hard as you pushed on it. If the bird pushes the air down with its wings, the air pushes back on the bird to the same degree. And so the bird is basically pushing air downwards with the same or greater force than the air than gravity is trying to pull the bird down, and that keeps the bird flying. So it's basically throwing air in one direction to push the bird in the opposite direction.
Andrew, thank you so much to you and the kids. Really appreciate it. We have 30 seconds, Chris, and people often ask us, why can't we do an hour of Dr. Chris Smith? And that is because you are so wanted by radio stations around the world that 30 minutes at 9:30 on a Friday is all we have from you. Also, all this is podcast on your website, thenakedscientist.com. Is that
you can grab this and I'll make sure I do this one. I'll get it ready tonight. So you go to nakedscientist.com/ask, A-S-K, and you can get all of this catalogue. And maybe once a month we could do a bonus and do an hour or something, Lester, if people really want us to do that. Why don't we think about doing that?
Chris, again, really appreciate it. The kids appreciate it. Andrew, we appreciate the kids.
Thanks,
Chris,
Andrew.
good weekend.
Thank you, Dr. Chris. Thank you, Lester.